Chart that I made that summarizes basically all of the information that we went through in the previous video, and we'll just keep referring to this throughout this section. So we have the three different cases. We have square root of a squared, where that a is a constant, square root of a squared minus x squared, square root of a squared plus x squared, the square root of x squared minus a squared. Here is what we should be doing. These are the substitutions we should be making in each one of those different situations. One other thing that I should note here that I didn't talk about before is that we should always be thinking about what values of theta these are defined for. So I included that in here. Okay, so without further ado, let's do some examples, and let's start off with examples that fall into this bucket. So our first one is going to be the integral of the square root of 16 minus x squared. Went over that. So this is falling into this bucket where a is going to be 4. So let's write down our decisions here. X is equal to 4 sine theta. So dx is equal to 4 cosine theta d theta. And that under the square root will equal, after substitutions, 4 cosine theta. Okay, so putting all of this together, so this integral ends up equaling, after a substitution, so x doesn't go in explicit anywhere, the downstairs becomes 4 cosine theta. And the dx, that becomes 4 cosine theta d theta. And so, hey, look, lots of things are going to cancel out. That all cancels out right there. And we are left with just the integral of 1 d theta, which, of course, is just theta plus c. Okay, so we've done our integral, but we're not done yet, because our final answer here, or what our answer is right now, which won't be our final answer, it's in terms of theta, and we want it to actually be in terms of x. So our final step now is to take we have x in terms of theta, and solving this for theta in terms of x over 4 is equal to sine theta, or taking inverse sine of both sides, inverse sine of x over 4 is equal to theta. And so when we see theta there, we're going to replace it with inverse sine of x over 4. So our final answer is arc sine of x over 4 plus our constant. So this is pretty typical procedure. We saw we had square root of 16 minus x squared. So that was in this bucket. So we just follow all of these choices to make. Point out that we didn't have to resort to this triangle. However, in future problems, we will have to resort to this triangle in order to make things work. Okay, so that's one example. Let's do a second example that hopefully will be instructive as well. Okay, so here we have the integral of just the square root of 1 minus x squared. So this is in the numerator instead of in the denominator like it was previously. Okay, so here a is going to be 1, and we'll make the same choices as we did before. So that is x is equal to sine theta, dx is equal to cosine theta d theta, and square root of 1 minus x squared, that will equal to cosine theta after substitution. And so what do we end up with? We end up with the integral of cosine theta, and then dx, that becomes cosine theta d theta. So now we have to integrate cosine squared theta d theta. Okay, so this is a pretty standard thing to do here. This will be a throwback to the previous section, how to integrate this. And so what are we going to do here? The best way to do this is we use our various identities. And to do this integral, let me pull out. I should have had this available earlier for me, but here's this. Remember this page from the previous section? We'll replace cosine squared x with 1/2 plus 1/2 cosine of 2x. And I said x there. Of course, here we're working with theta. So 1/2 plus 1/2 cosine of 2 theta d theta. And when we integrate this, we get 1/2 theta plus 1/2, and then this ends up as the integral of cosine is sine of 2 theta, and we also have to, let's see, when we integrate, there's a substitution here, an extra factor of 1/2 comes out here. So quick check here, the derivative of this gives us this, so everything's on the up and up. We've got this 2 theta hanging out here. We don't really want, it's a little bit difficult for us to deal with 2 thetas and stuff like that. We'd much rather deal with thetas. So we just use the second identity on this sheet. Now we'll use this third identity on the sheet in order to get everything back in terms of thetas and not in terms of 2 thetas. So 1/2 theta, so sine of 2 theta is equal to 2 sine theta cosine theta. And so next page, right now we're at 1/2 theta plus 1/2 sine theta cosine theta plus c. Okay, so far so good. Now we're at the point where we just want to substitute back in. We've done the integration in terms of theta as our answer. Now we just want it in terms of x and we'll be done. Okay, so our choice from before, x is equal to sine theta, so that is inverse sine of x is equal to theta. So this first term here will be 1/2 times inverse sine of x. Now we have to figure out what to do with sine theta and cosine theta. And for this one, for the first time, we're going to have to go to our triangle here and just look to see what's going on. Well, what is sine of theta in this case? Sine of theta is x over a. And x over a, that is just, a here is 1. So that is equal to x over 1. And now for cosine theta we can see from the triangle is square root of 1 minus x squared over a, which is 1. And so that is going to be square root of 1 minus x squared over 1, and then plus c. So here's our answer. It is now entirely in terms of x's, no more thetas here. So this will be our final answer. So let me just get rid of all the dividing by ones, make it slightly nicer. So here is our final answer. Okay, so what's the summary for this problem? We saw square root of 1 minus x squared, so we knew to go for this column of the chart. We knew to make these substitutions. So we crunch. We're doing some stuff from the last section. But then the big twist here is doing these substitutions at the very end, is going back to this triangle to figure out what are sine theta and cosine theta in terms of x. So that's the big thing to get from here. Okay, so let's end the section with a pre-class problem. So I want you to evaluate this integral, the integral of x times square root of 9 minus x squared. So you want to do it using trigonometric substitution, and after you do trig substitution, you'll use regular substitution to integrate the. You'll have an integral in terms of theta, and you want to substitute in terms of, let's say, u, in order to actually carry things out.